Today's notes are on section 5.4, complex numbers. So first we need to talk about some vocabulary. The first is an imaginary unit. It is represented by the letter I, which has the value of the square root of -1. Therefore, if we have I squared, we can replace it with -1. I is used to simplify radicals with negative numbers underneath them. A complex number in standard form is the constant or our real number plus our imaginary number. So again, A is the real number, BI is the imaginary term. So examples of standard form would be 3 plus 4i, or 5 minus 9i, or just an imaginary number by itself. On a complex plane, instead of an x-axis and a y-axis, we have a real axis and an imaginary axis. So if I was trying to plot the point -2, 3i, I would start at 0, 0, and I'd move left 2 along the real axis, and then up 3 along the imaginary axis in order to get my point A. For point B, I don't move along the real axis at all, but I move down 4 on the imaginary axes. And then for point C, I have a positive real number of 5, so I move 5 along the real axis, but then there's not an imaginary number, so we plot our real number as point C at the axis of 5. The next thing we're going to talk about are complex conjugates. You need to remember that a complex conjugate, if you have a plus 3b, the complex conjugate would be a minus 3b. So other examples would be 3 plus 5i and 3 minus 5i, -2 minus i, and -2 plus i. Noticing that the only thing that's changing is the sign between the real and the imaginary number. The sign out front is not changing. Alright, so looking at example 1 with solving, we're going to start by moving everything to one side. So we'll get 2x squared. Actually, sorry, scratch that. We're going to start by getting the x-axis by itself, or the x term by itself, our squared term. So I'm going to subtract 26 to get 2x squared equals -36. Then we're going to divide by 2 to get our x term by itself, so we get x squared equals -18. Then we're going to take the square root of both sides to get x by itself. So we end up with x is equal to a positive or negative square root of -18. The 18 we can break down to the square root of 9 times the square root of 2, where 9 is a perfect square. So this becomes 3 square root 2. And the negative that was underneath with the 18 gets pulled out as an I. So we want to remember that I is equal to the square root of -1. So anytime you have a negative underneath the square root, you're going to pull it out front as an I. So that gives us our answer to example 1. Try and do the same thing for example 2. Remember, get the squared term by itself, then take the square root of both sides, and if you end up with a negative underneath the square root, pull it out as an I. Next, we're going to look at adding or subtracting. Think of the i's as if they were variables. You're combining like terms, so I can only add real numbers together, and then I can combine imaginary numbers together. And in standard form, I want to list my real numbers first. When you try example 4, make sure that you remember to distribute the negative before you try and combine like terms. And then flip it over to look at example number 5. Alright, we're going to start the same way for multiplying, so the 5i is going to get distributed to each of my terms. So I'm going to get negative 10i plus 5i squared. Then we need to remember that I squared is equal to negative 1. So in my equation, instead of I squared, I'm going to plug in a negative 1 and simplify. So I get negative 10i minus 5, which in standard form is negative 5 minus 10i. Next, if I look at example 6, I'm going to start by multiplying the binomials together using FOIL. So I'll multiply the first two terms together, the outer two terms, the inner two terms, and the last two terms. So we get negative 7 plus 14i plus 4i minus 8i squared, and I can combine the I terms in the middle. Then we can't leave I squareds in our equation, so I can replace the I squared with a negative 1. So I end up with negative 7 plus 18i plus 8, so I can combine my real numbers together to get 1 plus 18i. Please try and do example 7 on your own. We are going to look at example 8 tomorrow in class. We'll start by looking at example 9 tonight. So if you're dividing, in order to simplify the denominator, you are going to multiply by the complex conjugate. So for 5i, the complex conjugate is negative 5i, and if I multiply the denominator by negative 5i, I also need to multiply the numerator by negative 5i. So in the numerator, that negative 5i gets distributed to both terms. So we get negative 5i minus 30i squared. In the denominator, 5i times negative 5i gives me negative 25i squared. Then, because we can't have I squared in our answer, I'm going to go through and replace all of the I squareds with -1. And I'm going to simplify again. So I get -5i plus 30 over positive 25. And I need to check if there's a number that goes into 5, 25, and 30. And that number is 5. So if I divide everything by 5, I get -I plus 6 over 5, which will lead me to my last step, which is just to put everything in standard form. When you're simplifying to go from this step here to this one, you can only simplify if a number goes into all of the terms. If it goes into one but not the other, you can't simplify the fraction at all. If you want, go ahead and try example 8. The complex conjugate would be 1 plus 2i. So you're going to have to FOIL both the numerator and the denominator. Otherwise, we will talk about example 8 tomorrow in class.